Now in this topic we have to find out electric field at an equilateral point. So this is our electric dipole, minus q and plus q, and distance between them is twice a. We take is by conveniently, and this is a, this is also a. O will be the midpoint of AB. So dipole axis is from minus q to plus q, and perpendicular of A and B will be your equatorial. This is your equatorial line, and this is the point of C where we need to find out the electric fields due to minus q and plus q. This minus q and plus q formed a electric dipole. Now let us suppose OP has a distance of r, and this is r and this is a, and this will be by the Pythagoras, this will be 90 degree. From the Pythagoras theorem, it will be square root of r square plus r square plus a square. Similarly, this will be r square plus a square. So now plus q, positive charge the electric fields away from the charge. So electric field at the point of P due to this positive charge will be from B to P. Now it has the value E plus Q, and electric field due to minus Q at the point of P is toward the minus Q. Now it has along the direction of PA. So resultant will be, I have make a parallelogram and whose adjacent vectors are this and this. Resultant will be along the diagonal. So diagonals will be their resultant electric fields. So since electric field at the point of P due to plus q and minus q at the same value, that value will be one upon 4π0 charge upon its square, charge upon this square also. So this resultant will be along the bisecting angle of this along this one. So this is theta, this is also theta. Now this is theta and this is the corresponding angle, it will be also theta. So now this E plus Q has the two components. One is along this one, another will be along this one. Same way E minus Q has two components. One is along this one, another is along this one. The vertical component will be cancelled out. The vertical component will be cancelled. Now this is E plus Q, its component along this one will be E sin theta. E sin theta component will be cancelled out by the E sin theta component of this one. Since we know that both these have the same value, therefore this will be cancelled by this. Only the component of this and this will be along this one, which is resultant field. Resultant electric field at P will be twice of either component. Yeah, I can say that E plus Q cos theta plus E minus Q cos theta, both have equal magnitude. E plus Q and E minus Q are the same one, so we can take this E times of E plus Q and cos theta. Now place the value of E plus Q and cos theta. Cos theta we have to calculate from here. Cos theta has the value A divided by hypotenuse A upon square root of r square a square. Finally, this value becomes 2 upon 1 upon 4 pi epsilon naught, and E plus Q has this value, Q divided by r square into a square multiplied cos theta. Cos theta has this value. Now if I simplify this resultant field will be, and also putting the value of P is equal to twice Q into A. This is the dipole moment of the system. Now finally we have 1 upon 4 pi epsilon naught, 2 QA will be P times R square plus A square, 1 plus its power is 1 and its power is half, it becomes 3 by 2. So now taking considerations of since if I take R is very far from these systems, and under this condition if I say that R greater A, so therefore 1 upon r square plus a square raised to the power 3 by 2 will be replaced by, we have to left a, and finally it becomes r square raised to the power 3 by 2. 2 is cancelled out, now it becomes 1 upon r cube. So now the field will be at the point of P. In the limiting case, 1 upon 4 pi epsilon naught, and charge now P dipole moment divided by r cube. So this is the value, this is resultant value, and one value is this one, this is the exact value, and this is the limiting value. Now equation number 2 will be our limiting value, 1 upon 4 pi epsilon naught P divided by r cube. Now what is the difference between electric fields at axial point and electric field at equatorial point? We already know that in equatorial point we have twice P upon r cube. In axial point we have axial point it has twice P upon r cube, and in equatorial point we have P upon r cube. Now the relation between them is E equatorial 2 times of E equatorial is equal to E axial. Field at the equatorial point, if I write this 1 upon 4 pi epsilon naught and twice P the dipole moment r cube, and E axial as the value 1 upon 4 pi epsilon naught P upon r cube. Therefore this result comes out. Now also it's a direction here. Directions in the case of the equatorial in the opposite of axis of the dipole is along this one. Direction of the resultant field at the point of P due to this system is just opposite of this dipole axis, dipole moment, just opposite of the dipole moment. Now along this one, so dipole moment had the direction from this.